2 plus 0 plus 0 plus 6 all to the power of 2 times 0 times 0 times 6. Okay, well, in the brackets we have 8, and the exponent is 0. So that's 8 to the power of 0. Anything to the power of 0 is 1. So the answer is A. Number 2, so we have 2 times 4 times 6 times 8 times 10, all negatives, and then you have 1, 2, 3, 4, 5. Okay, so what I will do is I'll just put it underneath. So we have 2, 4, 6, 8, 10, and then just divide it. We're dividing by 1, 2, 3, 4, 5. And these are negatives, right? So we got to put negatives, and then we have to put brackets. Okay. All right. So then this cancels with that to give 2. This cancels with that to get 2. This cancels with that to give 2. This cancels with that to give 2. And this cancels with that to give 2. And all of these, I believe, are negative, right? Yeah, because the negative sign still retains itself. And then therefore, when you multiply that, that's 32, but it retains a negative. So negative 32 is the answer. So that would be D. If x1 plus 1 scoops of ice cream costs $3, then x plus 1 plus 2x plus 2 scoops of ice cream costs. Okay, so x plus 1, and then we have 2x plus 2. So that's really just x plus 1 and then plus 2 times x plus 1. So they're saying that this is $3. So this is $3, and that's 2 times $3. So that's 3 plus 6, and therefore that is $9. And therefore, the answer to number 3 is D. If x minus 2 over x plus 2 is 8, then x minus 2 is okay. So x, the top, we can factor at x minus 2, x plus 2, all over x plus 2. And therefore, that cancels with that. So then you just have x minus 2 is equal to 8. And that's it. So that's B. 10x to the power of 100 is equal to 10x to the power of 100. Okay. So let's see here. So we got 10 to the power of 100, x to the power of 100. And then we have 10x to the power of 100. Okay. Well, the x to the power of 100 is cancel. So then we just have 10 to the power of 100 over 10 to the power of 1. And therefore, that's going to be 10 to the power of 99, right? Yeah. So that is C. One value of x for which x squared minus x is less than 0 is. Okay. Well, let's see. X squared minus x is less than 0. So let's factor out the x. X minus 1 is less than 0. Well, I don't know. I'm just going to go with the answer choices. If it's 2, it would be 2 times 1, which is 2, which is not less than 0. Okay, cross that out. If it's 1, it would be 0, which is not less than 0. A half, it would be a half times a half minus 1. So that's a half times minus a half, which is minus a quarter. And that is indeed less than 0. So the answer, just by checking the answers, is C. How many different positive integers satisfy x over 3 is less than 3? X over 3 is less than 3, so that means that x is less than 9. So if x is less than 9 and we want just positive integers, it would be 1, 2, 3, all of those guys up until 8. So 8 of them. So therefore the answer would be B. Rectangle R has an area of 48 and integral side lengths. The ratio of the length of R's longer side to that of its shorter side cannot be. Okay, so let's see here. We got 48 as the area, and well, we'll just call them A and B. Well, I should have called them length and width, but that's okay. Yeah, whatever, it's the same thing. So we know that A times B is 48, and what else do we know? Anything else? That's it. Oh, okay. So I guess this is just trial and error. So that means A and B, well, B is the longer side, right? So that means we could have if we have A and B, like if we make a table, what are the possibilities? And with the only thing that we know was A times B is 48. What are the possibilities with A being less than B, right? So we have 48 and 1. We have 24 and 2. 12 and 4. 12 and 4. Yeah, 12 and 4. I forgot the 16 and 3. And then 8 and 6. I think those are the only ones. So they want the ratio. So this ratio is 1 to 48, or 48 to 1. Let me see here. Yeah, the longer side to the shorter side. Okay, so I got to put the longer side first. This is 12 to 1. This is 3 to 1. This is, well, 16 to 3 because it cannot be reduced. And this is 4 to 3. So let's see here if I even did this right. Let's see here. It cannot be, okay, so it can be 3 to 1 because that's this guy. It can be 12 to 1 because that's this guy, and it can be 48 to 1. So the only one it cannot be is this 6 to 1. So that is the answer to the question B. The ratio of the number of teams that wear red jerseys to the number of teams that wear blue jerseys is 7 to 13. What percentage of the team in my league wear red jerseys? Okay, so we have the ratio 7 to 13. So that means if you have a total of, let's say you have 7 that wore the red jersey and 13 that wore the blue. So the percentage of red jerseys would be 7 over the total, which is 7 plus 13. So 7 over 20. And as a percentage, I believe that's 35%. So that would be C. The least common multiple of x squared and 2x. Okay, so we have LCM of x squared and 2x. So I put those exponents in for a reason. With least common multiple, you think largest. And I know that sounds paradoxical, but let me explain what I mean. Think largest. Largest what? Largest exponent for each prime number. Now, I have no idea if x is a prime number, but that's the only thing we have. So for x, the largest is 2, because we have a 2 here and a 1 here. So of those, the largest is 2. The only other prime number is 2. And, well, here technically it's 0 because there is no 2. So between this 0 and this 1, the largest is 1. So that is the LCM, which basically would be 2x squared. And therefore, number 10, the answer looks to me like B. X to the power of 18 plus 2 times x to the 17 plus x to the power of 16 is equal to. Okay, well, let's see here. First, I'd factor out the x to the 16. That's going to give me x squared plus 2x plus 1. Is that right? I think so. And then what? Oh, then you got this side, this question mark, and then x plus 1 squared. And then this in the bracket, I believe, is x plus 1 all squared. Yeah. So therefore, that question mark is just x to the power of 16. So therefore, number 11 is D. When I was as sick as a dog, I spent 2x absolute value plus minus x absolute value days in the hospital. I was in the hospital for a total of how many days? Okay, interesting question here. I guess we have to use the what is it called? The properties of these absolute values. So this basically breaks up into 2 and x like that. Hold on, let me write it properly. And then this is basically the absolute value is always a positive number, so it's the same as this absolute value of x. So then this is just 2 absolute value of x plus absolute value of x, so 3 times the absolute value of x. So that's all that is. It's a very strange question. I'm not even sure what they were trying to get at there. Just trying to test out our the properties of absolute values, I guess. X is 1 billion. Which of the following has the greatest value? Okay. I guess I have to convert all these. So let's do that. So this first one, x to the 100 to the square root, is the square root of this is the same as a half exponent, so that's x to the 50. The next one, well, that's nothing to do there. That's just x to the 20. The next one, x to the 10 times x to the 10 half. So that's x to the 10 times x to the 5, which is x to the 15. And then the last one, x2 to the power of 2, x to the 50 to the half, x2, x to the 25, x to the 27. Okay, so regardless of what x is, which one of these is going to be the largest value? Well, it's pretty obvious. If it's this one, because you're comparing these four, and as long as x is a positive number, the x to the 50 will obviously be the largest, so the greatest value. So that 13 therefore would be A. The product of all real values of x that satisfy x squared minus 2006 equals 0. Okay, so x squared minus 2006 is 0. Therefore x squared is equal to 2006. Therefore x is equal to plus or minus the square root of 2006. So those are the two values. So they want the product, right? So the product would be the square root of 2006 times the negative square root of 2006. So that looks to me like minus 2006. And therefore number 14 is D. A square whose area is x plus 4 to the power of 4 has a perimeter of. So we have a square, and we have the sides, and n squared would be x plus 1 to the power of 4. So that means x is x plus 1 squared. The perimeter is equal to 4n, and therefore that would be 4 times x plus 1 to the power of 2. So that looks to me like 15 is A. Okay, 16, this whole thing here, let's see, what do we got? We got W2, W4 all the way to W50, and on the bottom we got W1, 3, 5 all the way to 49. Okay. Interesting. Well, if I take these one at a time, the first one and the first one on the top, first one on the bottom, that leaves me with W to the power of 1. Same thing, the next one, W4, W3, using the exponent laws, you'd have W to the power of 1. And then so on. 6 and 5, it would be 6 minus 5, which is W to the power of 1. And you just keep going all the way to the end, W to the power of 1, W to the power of 1. So how many of these do we have? We have, be careful, not 50. We have, on the top, it's every even number. So it's 50 divided by 2, so 25. So it would be W to the 25. So 16 would be B. The number of fish in my fishbowl equals the number of positive integers less than 100 that are both perfect squares and perfect cubes. How many fish are in my fishbowl? Okay, well, first let me list the perfect squares, these guys, that are less than 100. We got 1, 4, 9, 16, 25, 36, 49, 64, and then 81, right? So those are the perfect squares. Now cubes, it'd be a shorter list. It would be 1, 8, 27, 64, and that's it, because it's got to be less than 100. So now we want something that's in both lists. The 1 is in both lists, and anything else? 64. So only two numbers are both squares and cubes that are less than 100, positive numbers. So therefore number 17, the answer would be B. If each of 3 parallel lines has an integral slope, then the product of these slopes cannot be. Okay. Well, let's see here. We've got three parallel lines, right? So they have this same, slope. Yeah, if they're parallel, they have the same slope. And then when you take the three slopes and multiply them together, that's what the product is, then what cannot be? Okay, I think I understand. So I'm going to try to get these answer choices and see what happens. So if the slopes are all 1, 1, 1, 1, then the product would be 1 times 1 times 1, the product, which is 1. So this is possible. So I guess that's not the answer, because they want the one that's not possible. If these slopes were all 0, not for these lines, but three other parallel lines where the slope is 0, then the product would be 0. So this is possible, so therefore that's not the answer. If the slopes were on -1, then the product would be -1. And therefore this is possible, and therefore that's not the answer. So the answer to this question by process of elimination would be D. If y is equal to 2x plus 5 and 3y is equal to ax plus b have the same graph, then a plus b is. Okay. All right. Well, if this is that, then 3y would be 3 times y, which is 2x plus 5. So then that's 6x plus 15. So that means this is equal to ax plus b. And then if you match the coefficient, it looks to me like a is 6 and b is 15. And therefore a plus b would be 6 plus 15, which is 21. So 19 is C. My age in years is a 2-digit number. Reversing the digits of my age results in my age 18 years ago. What is the difference between the digits of my age? Okay, so let's say your age is AB. Those are the 2 digits. And then if you subtract, that's what difference means. The reverse, which is BA. And they're saying that's 18. So that's the math, basically. So this is the equivalent of 10a plus b minus 10b plus a, correct? So that would be 9a minus 9b is 18. And then if you factor out the 9, it would be a minus b is equal to 2. A minus b is equal to 2. What are they asking? What is the difference between the digits of my age? Well, there we go. This is the difference. A minus b, which is 2. Okay, so that's all they're asking for there. If the square root of m times a times t times h is equal to m times a times t, then the value of h must be m times a times t times h, m times a times t. Okay. So if we break this up, it's going to be m times a times t, and then times that by h, with this m times a times t like that. So the square root of h would be m times a times t over m times a times t like that. So that basically means that the square root of h is m times a times t square root. And therefore, if we square both sides, h would be equal to m times a times t. So, therefore, that would be A for 21. If the total value of d dimes in n nickels equals the value of n minus d quarters, then the d to n ratio is. So, we have 10d because that's the value of 5n. Right, we have 10 cents and 5 cents is n minus d times 25, right? Quarters, which is 25 cents. Okay, shouldn't be too bad here. So 10d plus 5n is equal to 25n minus 25d. So that's 35d is equal to 20n, and therefore d over n is equal to 20 over 35, which is 4 over 7. 4 over 7 is the answer, and therefore that would be A. From the 99 integers, choose n different integers. If the product of these n integers is 100, the greatest possible value of n is. Okay, so basically a bunch of integers that multiply together to give 100. Okay, so what is 100? 100 is 2 times 2 times 5 times 5, correct? Yeah. Now they're different integers, so I got to fiddle around with this. So we could have, let's say, 2 times 50, so that would be 2 integers. But I'm sure the answer is more than that. Or you could have 2 times 5 times 10, that's 3 integers. So it's not going to be A, because they want the greatest. And a little tricky here, because the 1 is there too, so it could be 1 times 2 times 5 times 10. That would be 4 integers. So, and I don't think you could get 5 unless you repeated the same integer twice. But that's not allowed because they want different integers. So number 23, I'm pretty confident, is C. Okay, this big long thing, let's see here, is undefined. So I guess I probably don't even have to solve it. Or maybe I do. Well, it's undefined if x is minus 2006, right? Because that would make the denominator 0. So that's one value. Are there any other values for which it would be undefined? I think I would have to fiddle around with this then. Yeah, it would be also undefined if this denominator is equal to 0. This whole thing is equal to 0. So that's what I have to do now. Okay, no problem. So put this on the other side. X plus 2006. Okay, I multiply, cross multiply. Like that. All right, here. Oh boy, this is a quadratic, right? No, that's messy. By inspection, actually, I noticed that if you set x equal to -1, this would satisfy the equation, right? Because it'd be 2005 in the bracket, and you multiply by -1 to get minus 2001. So x equals -1 is also a value that would make this undefined, this whole thing. So we got 2 values, and therefore the answer would be B, 24. What is the least positive integer whose square is divisible by 4 to the power of 144? Okay, so we have some positive integer whose square is divisible by 4 to the power of 144. Okay. Well, I guess the least would be just if that was equal to, if n squared was equal to 4 to the power of 144. That would be the least. And therefore, n would be equal to 4 to the power of 72. Correct? And I think that's it. 25, therefore, would be B. X squared plus symbol plus 1 over x plus 1 is equal to x minus y plus 1 over x plus y. Okay, well, let's see. Interesting here. I'm just trying to think what's the least amount of work. Well, let's just work with this guy here. So we have x minus y plus 1 over x plus y. And of course, we got to add the, like that, common denominator. So it'd be x squared minus y minus xy plus xy minus y squared plus 1 over x plus y. And they're saying that is equal to x squared plus this symbol plus 1 over x plus y. So that symbol obviously is equal to minus y squared. So 26 therefore would be 8. If x squared minus a squared is equal to 0 has two real roots, then something also has two real roots. Okay. Well, let's see here. We have x squared minus a squared is equal to 0. And therefore x minus a times x plus a is equal to 0. And therefore x is equal to a and negative a. Correct? So then something else also has two real roots. Well, this has just 1, x equals a. This is just 1, x equals minus a. This one has no real roots because x squared would have to equal minus a squared, and therefore you'd have to take the root of a negative, and that's no longer real. And therefore, by process of elimination, it's this guy. And then you can verify that these actually do satisfy that equation, and they do. If AB is in quadrant 2, then minus A minus B is in quadrant. Okay, so what are the quadrants? Does anybody remember? This is the first quadrant, this is the second quadrant, this is the third quadrant, and I believe this is the fourth quadrant. So quadrant 2, you have minus A minus B. Minus A minus B is in quadrant 2. Okay. So something here. So let's say this is 3 and this is minus 3. So this is 3 minus 3. So if you're doing the negatives, it would be minus 3, 3. So minus 3, 3 would be minus 3, 3 would be approximately here. So that looks like quadrant 4 to me. So that would be D for number 28. In the sequence 4, 8, 64, and so on, each term after the first is the product of all the positive integer factors of the previous term. What is the fourth term of the sequence? Okay, so let's see. The 4, it starts off, and then the integral factors of 4 are 2, 2. So is the product of all the positive integral factors, 2, 2, and 4 of this guy. So then what they do is they multiply these 3 together to get the next term. Is that right? No, just 1, 2, and 4. Sorry, 1, 2, and 4. Yeah, 1, 2, and 4. Those are the integral factors. So then they multiply these guys to get the next term. Okay, I got it. Okay. And then the same thing, what are the integer factors of 8? It would be 1, 2, 4, and 8. And then they multiply those guys together to get the next term. So that would be 8 times 8. Okay, that's how they got 64. All right. So then they're saying, what is the fourth? So they just want you to get the next term. Okay, that's not a problem. What are the integer factors of 64? It would be 1, 2, 4, 8, 16, 32, and 64. And then you got to multiply all these guys together. And then interestingly, if you look, the answers are in factors of 2. So we can do that. It's probably, so we have 2 to the power of 1, 2 to the power of 2. These guys, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, and 2 to the power of 6. And if you multiply all these together, you'd add the exponents. So it'd be 1 plus 2 plus 3 plus 4 plus 5 plus 6, which is 3, 6, 10, 15, 21. So 22 to the power of 21. So therefore, number 29 would be B. Any x which satisfies something also satisfies that. Okay. So we have 1 minus the absolute value of x plus 1 is less than 0. So that means that 1 is less than the absolute value of x plus 1. So that means that well, if x plus 1 is greater than 0, then this would just drop to this, x plus 1. So that means x would be greater than 0. So let's just keep that for now. And if x plus 1 was less than 0, and then this would become 1 is less than minus x plus 1, like that. So that would mean 1 is less than minus x minus 1, so therefore x would be less than minus 2. So these are our two findings, and of those, this one looks to me like answer choice A for number 30.